Let's study ninth standard physics, chapter 2 numericals from the Oswal textbook. First sum. A person is jogging on a circular field. He jogs from point A to point B of the field as shown in the figure. This is the figure. Notice that it's a semicircle. He's not coming back to the original position because in that case, displacement would have been 0 and distance would have been circumference, which is 2 pi r. But semicircle. So they have asked for the distance and the displacement, and the radius is given. Well, distance is half of the circumference, which is pi r. Substitute the values and you get the answer. Displacement from A to B is the diameter, which is twice of radius. So that comes out to be 1000 meters. Third sum. A man riding a bicycle covers this much distance in this much time. Calculate the speed in SI units. So let's convert the data in SI units. This will be 1500 meters and this will be 2.5 into 60 seconds. And then we can use the formula speed is equal to distance upon time to get the answer 10 meters per second. Fifth sum. A boy is traveling in a bus moving with a velocity of 45 kilometers per hour. How do we convert kilometers per hour into meters per second? We do into 5 upon 18. How much distance will the boy travel in 1 minute and 1 second? First of all, convert it into meters per second, which is 12.5. Then use the formula distance is velocity into time. Here the time is 60 seconds. So the distance is 750 meters. And in part B, the time is 1 second. So the distance will be 12.5 meters. Now the seventh sum. A bus takes 5 hours to travel from Bengaluru to Chennai. If it travels with this much speed in the first half, meaning half the distance, not half the time, and the second half of the journey with a greater speed in the second half, find the distance traveled by the bus. You see in the first half he was passing through Bengaluru, which is overcrowded, full of traffic jams, hence he was slower. In such sums we should use the table method. Distance, let the total distance, which is what we have to find, be x. So the first half will be x upon 2 kilometers and x upon 2 kilometers. Speed data is given. We have to find x. Total time is given. So let's find the total time in terms of x to create an equation. Time is distance upon speed. So we find the time of the first case and the second case. And the total should be 5 hours. So that's the equation which we wanted. Remove x upon 2 common. Now this is just math. Here again you'll find LCM, so that you can have a common denominator 825. Cross multiply and get the answer of x as 317.3 kilometers. I suggest take a flight. Ninth sum. A train travels with a uniform speed of 20 kilometers per hour and covers a distance of 40 kilometers from station A, and the total distance between A and B is 160 kilometers. So again there are two cases. In the first case the distance was 40 kilometers and the total distance is 160 kilometers. So in the second case it will be 160 minus 40, 120 kilometers. Also they have given that in the first case the speed was 20 kilometers per hour and they want the speed in the second case so that the average speed is 40 kilometers per hour. So initially he was traveling at 20 kilometers per hour. What should the new speed be for the second part so that the average comes out to be 40? And we can't use the average formula here. We'll have to calculate it in a different way. First of all, the time taken for the first part of the journey is distance upon speed, which is 2 hours. Then the total time taken, which was his target time, was 4 hours, out of which the first 2 hours he was traveling rather slowly. He has only 2 hours left for the second part. So if he wants to cover the remaining 120 kilometers in the remaining 2 hours, what should be his speed? Well, speed is distance upon time, which incidentally is 60 kilometers per hour. But it could have been any other value also, in decimal as well. This was just a coincidence that the 40 is the average of 20 and 60. Next, the 11th sum. A body starts from rest, means u is 0. It acquires a velocity of 30 meters per second. So v is 30. Time is given, acceleration is asked. Always write the data first, it makes things easy. Formula is v minus u upon t. Answer is 6 meters per second squared. 13 sum. A car is traveling at a velocity of 36 kilometers per hour and time is 10 seconds, and now the new velocity is 54 kilometers per hour. Find the acceleration. Well, you could have converted them into meters per second individually, but what I'm going to do is I'm going to find the difference first, 18 kilometers per hour, v minus u, and convert this into meters per second, so that I have to do it only once, because in the formula we have v minus u already. So I'm going to use the formula and the value of v minus u directly as 5 meters per second out here, and time is 10 seconds, so I get the acceleration answer as 0.5 meters per second squared. Next, the 15th sum. A car is moving with a velocity of 72 kilometers per hour, converted to meters per second into 5 upon 18, is brought to rest, means v is 0, and the time is given, so find the acceleration, or rather the retardation. So the acceleration formula is v minus u upon t. Definitely we'll get a negative answer because it was a retardation, but when we write retardation in the end, don't put the negative sign, because retardation by definition is negative acceleration. Now the 18th sum. From the data given, draw a VT graph. So let's do that first. VT, make sure it's equidistant, equispaced. I see uniform velocity for the first 5 seconds, then retardation, uniform acceleration, again uniform retardation. Okay, they want first of all a retardation between 5 and 7 seconds and acceleration between 7 and 10 seconds. Well, we always use a slope. So retardation from 5 and 7 seconds. It's a good habit to always give the heading 5 to 7 seconds. So that will be height upon base. So retardation, height upon the base. So that's v minus u, that's 20 minus 10, or rather 10 minus 20, and the base is 2 seconds. No need for a negative sign because we are finding retardation, not acceleration. So the answer is 5 meters per second square. Again, acceleration from 7 to 10 seconds. Always give the heading 7 to 10 seconds. So it's again height upon base of this slope of this graph. So height is again 10 and the base is 3. So 10 upon 3 is 3.33 meters per second squared. C. Find the total distance in 15 seconds and the average velocity. Well, the total distance is found by finding the area. Now, there's no single formula to find the area of this, whatever figure that is. So we're going to break it up into 4 figures. A rectangle, a trapezium, and a triangle. And we'll find the areas separately. This will be length into breadth. This will be trapezium. So half into sum of parallel sides into height. Parallel side, this is 20 and this is 10 and the height is 2, by the way. And for this trapezium, again the parallel sides are 10 and 20 and the height is 3. And for triangle, it's half into base into height. So using these formulae, I found the respective areas and give the headings. First 5 seconds, then 2 seconds, then 3 seconds, then 5 seconds, last 5 seconds. And then total distances, add all the 4 areas and you get the answer 225 meters. And the average velocity is total displacement upon total time, which comes out to be 15 meters per second. Remember, in such VT graphs, if it goes down, it doesn't mean it's coming back to the origin. It's just that it is retarding, but it's moving forward, just like we should in life. 20th sum. In this diagram, again, it's a ST graph. Describe the motion of the car. Well, here you should write that for the first 10 seconds, it's uniform velocity. Then it's at rest from 10 to 30 seconds. And then from 30 to 50, again, write uniform velocity. Don't talk about acceleration because it's an ST graph. And by the way, there is no acceleration at all in this entire journey. Find the velocity of the car from 10 to 50 seconds. 10 to 50. Time is 40 seconds and the total distance is, it was at 10 meters already and finally it's at 50 meters. So the distance covered is 40 meters in 40 seconds. So the velocity is 40 upon 40, 1 meter per second. Similarly, they want the velocity in the first 30 seconds. So again, in the first 30 seconds, it covers just 10 meters. Yeah, it's at rest, but totally in 30 seconds, it has covered 10 meters. It had actually covered it in the first 10 seconds itself. But the average velocity for the first 30 seconds is 10 upon 30. That is 0.33 meters per second. 22nd sum. A. Calculate the distance traveled by the car when it is moving with a uniform velocity of 15 meters per second. So they only want the distance from 2 to 6 seconds. If they wanted the total distance, we could have found the area of the trapezium, but they just want AB, area under the graph. That's a rectangle, that's length into breadth, which is coming out to be 60 meters. Also, they want in which part of the graph the acceleration of the car is 0. Of course, the AB part, which is 2 to 6 seconds. And compare the magnitude of acceleration with the magnitude of retardation. Well, acceleration happens in the first 2 seconds, that's the slope, that is height upon base. And retardation happens in the last 2 seconds, which is again the slope, height upon base. And incidentally, it was symmetrical, so the answer came out to be same, 7.5 and 7.5. So the ratio is 1:1. Whenever they say compare, they mean they want the ratio. Now, first question is interpret the graph. So as I said, you have to explain each and every part, what is happening. Uniform acceleration, uniform velocity, uniform acceleration, uniform retardation, mention that. Next, they want the time interval during which the body was moving with uniform velocity. Well, that will be 3 to 5 seconds, that is AB. Mention AB out there. Next, state the time interval during which the body was moving with uniform retardation, that is CD. That is 7 to 10 seconds. Mention that. Mention both the time and the labeling. What is the maximum velocity reached? Well, that's 40 meters per second. Find the acceleration in the first 3 seconds, that's the slope. And the distance traveled in the last 3 seconds, that's the area. So here's how we solve it. Keep looking at the graph to understand it. Don't just copy paste. Slope is 10 meters per second squared. That's the acceleration. And the displacement, it's always good to give headings, the time interval, so that you don't get confused. So area of a triangle is coming out to be 60 meters. Next, the 25th sum. What is the total distance traveled by the car? So clearly I have to find two distances, this trapezium and this trapezium. So notice that A is at 5 seconds and B is at 10 seconds, C is at 13 seconds, D is at 16, E is at 21 seconds, F is at 25 seconds. So be careful about that. So you find the two areas separately, the formula of trapeziums, and you add them up, you get the total distance. And the average velocity is, of course, the total distance upon total time, which comes out to be 4.9 meters per second. Next, they want the acceleration of the car in section DE. DE acceleration will be slope, that is height upon base. That is 5 upon 5, 1 meters per second squared. Give the headings of time always. 27 sum. A racing car initially at rest starts with a uniform acceleration. Okay. Initially at rest means u is equal to 0. A is given. Time is given. Find the distance. Well, always write the data and then decide which of the three kinematic equations you should use. I choose S is equal to ut plus half at square because only that will work. U is 0. Yay, this goes away. So I get the answer as 250 meters. 29 sum. A car is traveling with a velocity of 27 meters per second. That's u. When brakes are applied, so definitely it will be retardation. It undergoes a uniform retardation. So A will be minus 1.2. Don't forget the minus sign here. What will be the distance covered when it comes to stop? So V is 0. So using this data, the only formula that comes to my mind is V square is equal to U square plus 2AS, because time is not given and the other two formulae have T. Substitute the values, don't forget the minus sign, and solve. This is just math, and S is 303.75 meters. Now the 32nd sum. A bus initially at rest, so U is 0, acquires a velocity of 72 kilometers per hour, that is 20 meters per second. Time is given. Find the acceleration, average velocity, distance. So easy. Acceleration, V minus U upon T. Average velocity, since it was uniform acceleration, since there was no change in direction, I can now use a formula U plus V upon 2. We cannot use it every time, only in case of uniform acceleration. So the average velocity is 10 meters per second. And the distance, I'll use this formula to get the answer as 50 meters. Now, the 33rd sum. A bullet is fired towards a wall with a velocity of 50 meters per second. It stops, so final velocity is 0. Penetrating 10 centimeters, that is 0.1 meters. Find the retardation. Well, again, the data is given. Use a formula. Substitute. Of course, the A's value will be negative, so that the retardation is written positively. 12,500 meters per second squared. 35th sum. A trolley starts moving. Starts moving means initial velocity was 0. Acceleration is given in centimeters per second squared. You can convert it to meters, but I'm going to choose to keep it as it is. Time is given 5 seconds and final velocity is asked. Well, V is equal to U plus AT, so that comes out to be 50 centimeters per second or 5 meters per second. 38th sum. A train starts from rest, accelerates for 15 seconds, maintains constant speed at 300 seconds, and then retards for the last 50 seconds. Well, the best way to solve this is by using the graph. So for the first 15 seconds, acceleration, that value is given. Final velocity, unknown. The next 300 seconds, constant velocity. And the last 50 seconds, uniform retardation. First question, always give the headings of time. What is the final velocity achieved? Well, v is equal to u plus at is 30 meters per second. Second question, what is the acceleration in the last 50 seconds? Well, that's the slope. It is height upon base, but what is the height? Well, fortunately, I have found v, it is 30, so the height is 30 and the base is 50 seconds. So that's minus 0.6, by the way. Don't forget the negative sign because there was a negative slope. But when you write retardation, no need to put the negative sign, 0.6 meters per second squared. Total distance traveled in the entire time interval. Well, that's just the area of the trapezium, no need to solve it separately. So we have the formula. The top parallel side is 300, the bottom is 365, height is 30. You get 9975 meters. The answer behind the textbook is wrong. Average velocity is total distance upon total time, so we get 27.32 meters per second. Next, 39 sum. A coin is dropped. Now, whenever we have sums where something is dropped, that is downward journey or thrown up, upward journey, always give that heading. So when a coin is dropped, I should mention downward journey because that makes me remember that u will be 0 always and g will be positive, and when the value of g is not given, take it as 9.8 meters per second square. Height is given, by the way, and they want the final velocity. Substitute the values and you get the answer. That's a difficult calculation. So what I've done is I have got rid of the decimal. They are perfect squares, good, but the root 10 is remaining. Rationalize the denominator into root 10 into root 10, so the denominator becomes 10. 0 0 cut, root 10 is still left, but you should remember the root value of 10 is 3.16, so I get the answer as 88.48 meters per second. Plus or minus 0.1 is allowed in exams. If you've used 10 meters per second squared, you may get a different answer. You have to ask your teacher what she wants. Usually in exam they give the value of g, and they also want the time taken to reach the ground. Well, that's a straightforward formula. V is equal to u plus gt. You can use at also, doesn't make a difference. And time comes out to be approximately 9 seconds, 9.0 something seconds. 41st sum. Yeah, you have to solve till 2 decimals everywhere. On the moon, an object is dropped from a height of 2 meters. So height is given, acceleration due to gravity is given, which is different from that of Earth. Determine the time and the time it takes. So again, it's a downward journey. That means u is 0, which was not even mentioned in the question, but you need to remember to write it because it's a downward journey, so that you can use a formula to calculate the time, which is coming out to be some non-perfect square number. So I'm going to approximate it. I'm going to make this denominator 169, so I get roughly 20.13, and I get a rough answer of 1.53 seconds, which should be accepted by school teacher. Otherwise, she'll be expecting you to do some weird long calculations, which is not supposed to be done by 9th standard kids. All the best convincing your school teacher. 44th sum. A ball is thrown vertically upwards. Okay, it's upward journey. So this means the final velocity will now be 0 in upward journey always. And g is negative. Remember this in upward journey. And the initial velocity was given. So they want the height to which it will reach. So I'm going to use this formula. And height comes out to be 31.88 meters. Next, they want how long does it take to reach its highest point, the time. Well, v is equal to u plus gt. I don't like to use minus gt and all that. Rather, when substituting the value of g, I remember to put a minus sign because it was upward journey. So the time comes out to be 2.55 seconds. Next, they want the downward journey time. How much time does it take for it to come back down? Well, it's symmetrical, upward journey and downward journey. So the downward journey time will be same, 2.55 seconds, no need to calculate. Not only that, the final velocity in the downward journey will be exactly equal to the velocity with which it was thrown upward. So it will be 25 meters per second. Again, no need to calculate that. Of course, here we are assuming that there is no air resistance. Hi students, this is AJ sir. If you like this video, press the like button. If you would like to enroll for my online test series or online lectures, email me or message me on Instagram. Check the description for more information.